This time I want to look at multiplying integers. One of the first things I have to understand is, what are the different symbols for multiplication when we did on paper? Uh, so for us, early on we used the X as multiplication symbol. Then we used the dot. And then what we're going to use mostly here in our course is parentheses for multiplication. So, if I give you 5 times 3, we could also say 5 times 3, or we can say 5 in parentheses 3. These would all be equivalent. The one we like is this 5 times 3. Now, what can multiplication mean? Well, 5 times 3 can mean 5 threes added together. So 5 times 3 could mean 3 plus 3 plus 3 plus 3 plus 3. 1, 2, 3, 4, 5. So if we add those together, 3, 6, 9, 12, 15. So what we're picking up on is 5 times 3 is the same thing as 3 plus 3 plus 3 plus 3 plus 3, which results in a 15. Most of us just skip the middle step and just know as a math fact, 5 times 3 is 15. Note though, if we go 3 times 5, this is the same thing as 3 fives. So actually, this is equivalent to 5 plus 5 plus 5. So 3 times 5 is the same thing as 5 plus 5 plus 5, and that's 5, 10, 15. So notice that when it comes to multiplication, when you multiply, order will not matter. 5 times 3 is the same thing as 3 times 5. So if you put it into a calculator invertly, if you will, backwards, you're still going to get the same result. So no harm, no foul. So keep that in mind. But mathematically, 5 times 3 means 5 threes added together. 3 times 5 is 3 fives added together. But in the end, the result is the same. So again, multiplying integers means you're finding the product. So if I do this, the product would be 15. That's the answer. So in working with positive negative numbers, you have to understand there's some rules that we need to pay attention to when working with positive negative numbers, because integers, like I said, are going to be working with positive and negative numbers. So some of the rules you may have learned is a positive times a positive is a positive, a negative times a negative is a positive times a negative is a negative, and a negative times a positive is a negative. So those are some of the rules. So one of the questions is, is why do these uh, rules work? Well, as we were saying earlier, multiplying is the same thing as repeated addition, if you will, repeated adding. So keep in mind, 3 times 4 is the same thing as adding 4 threes, or I'm sorry, adding 4 3 times. So 3 times 4 means 3 fours. Or in other words, 3 times 4 is the same thing as 4 plus 4 plus 4. So keep that in mind. The answer would be 12. So we know that a positive times a positive is still going to be a positive. Now, a negative times a negative, that's a little bit trickier. One thing we have to pick up in math is the dash can mean to take the opposite of what's inside the parentheses, as I mentioned earlier in adding and subtracting integers. So if I have, say, the opposite, or if I have a negative 3, the negative 3 is also the same thing as the opposite of a 3. So I can actually pull the negative out and put a positive 3 in the parentheses. So negative 3 is the same thing as it's equivalent to the opposite of a 3. Similarly, negative 4 is the same thing as the opposite of a positive 4. So mathematically, instead of saying a negative 3, we can actually say the opposite of a 3. And then what we're going to do, I'm going to use a dot here just for the heck of it, times, instead of saying a negative 4, we can say the opposite of a 4. So mathematically, these dashes are actually our opposite symbols. So what I can do is I can pull these opposite symbols out in front and put 3 times 4 in the end. The nice thing about multiplication is you can actually go ahead and multiply the 3 times 4 to start with. So I have these two dashes and I have this 12. So what this really means to do is to take the opposite twice. Well, if I take the opposite of 12, if I do that math, the opposite of a 12 is actually going to turn into a negative 12. So this math actually turns into the opposite of a negative 12. But what's the opposite of a negative 12? Well, the opposite of a negative 12 is actually a positive 12. So what we learn is a negative times negative is actually going to be a positive from that concept. So as we move forward, you know, if I have this 5 times negative 2, notice that if we have a positive times negative, the answer is going to be a negative 10. There's two ways of looking at this. One way is I could say, well, that's 5 negative 2s. That's a negative 2 plus a negative 2 plus a negative 2 plus a negative 2 plus a negative 2. So what we have is a debt and a debt and a debt and a debt and a debt. So we just have a big old debt. 2, 4, 6, 8, $10 of debt or negative 10. Now another way to do it is I can write this as 5 times. Now instead of saying a negative 2, I can pull the negative out and call it an opposite. And I'm just going to pull that all the way out in front. And this is now going to be an opposite symbol, and I'm just going to put the 2 inside here. So another way to do this is I could say 5 times 2 is 10, but this dash actually says to take the opposite. So the opposite of a 10 becomes then a negative 10. That's another way of thinking. So that's the direction I'm going to go into is that. So when I see this negative 6 times this positive 3, I'm actually seeing this as the opposite of 6 times this 3. So mathematically, what I'm doing is multiplying 6 times 3 is 18. And then what's the opposite of an 18? That's going to be a negative 18. So you start to see a pattern involving negatives. If you're multiplying two negatives, the answer is going to be a positive. If you're only multiplying one negative, the answer is still going to be negative. So when it comes to multiplying, you want to multiply the numbers without the signs first, and then decide what the sign should be. So most commonly in algebra, if there's an odd number of negatives in the problem, the answer is going to be negative. If there's an even number of negatives, the answer is going to be a positive. And then just always check your work by looking at the signs. So if I gave you an example of negative 1 times negative 2 times negative 3, mathematically, what I could do is multiply without the signs. So I can multiply this 1 times this 2 times this 3. So 1 times 2 is 2, and 2 times 3 is 6. And then I count the signs. There's 1 negative, 2 negative, 3 negatives. Well, that's an odd number of negatives. Since there's an odd number of negatives, the answer's got to still be negative. So think of it like a light switch. One negative is going to flip it negative. The second negative is going to flip it back to a positive. The third negative is going to flip it back to a negative. So you can also think of this in terms of a light switch. So you're a little light switch guy. I don't know if I can draw a light switch. So a little light switch guy, something like that. Got the little switch there. Got off and on there. So one negative is negative, two negatives is positive, the third negative is back to a negative. So it kind of goes back and forth. So again, if I have negative 2 times negative 3, notice that a negative times a negative is actually going to be a positive 6 since we only have two negatives there. So we have that going on. All right, so I'll stop there on multiplication.